Okay folks, our lesson this morning, as you can see, trigonometry in 3 dimensions. So here's a 3-dimensional shape, a cuboid, and we're trying to find the angle HBD. First thing to do would be to draw that angle in on the diagram. So from H to B to D, that gives you the angle there marked in yellow. We're going to call that angle X. That's the angle we're trying to find. Angle HDB is 90 degrees. It's a right angled triangle you can see there. So we mark in the 90 degrees. And if I redraw that triangle on the left hand side there, HD is 8 centimeters because that is the height of the cuboid. And we need to find DB. Going back to the original cuboid, ABCD, the base, is a rectangle. And therefore, we've got a 90 degree angle there at A, and I'm going to redraw that base, and I'm going to mark in DB because it's DB, the length that we want. So in order to find DB, as you can probably see, we need to use nothing more than Pythagoras there. DB squared is 10 squared plus 7 squared, and that gives us DB is a square root of 149. We then put DB back into our triangle, and therefore we're going to be able to find X using SOHCAHTOA. So tan X is opposite over adjacent, so that's 8 over the square root of 149, and that gives us an angle of 33.2 degrees. Here's example 2. First thing we should do is mark the angle in from G to A to C. That's the angle marked in yellow. We'll call that X. And once again, the angle GCA is a right angle. That's a right angle triangle you can see that you've just drawn in. So we'll redraw that triangle flat. And in order to find X, we could do with finding the length AC. Once again, we go back to our base because AC is the diagonal in the base. It's a rectangle, and so we'll draw that rectangle flat, marking AC, and we can then see, using Pythagoras, that AC squared is 12 squared plus 8 squared, and therefore gives us AC is the square root of 208. We mark that in on our triangle, and once again, we're going to find X using SOHCAHTOA. It's going to be the tangent ratio. Tan X is opposite over adjacent, so that's 9 over the square root of 208. And that gives us X is 32.0 degrees. In example 3, we have a pyramid. And we're going to see 2 examples of a pyramid, and you just note the 2 different types. First, we're finding EAC, mark the angle in, and note this is an angle across the base of the pyramid. In order to find this, we drop a vertical down from E, that's the vertex, the apex of the pyramid, down to M, and M is the midpoint of the rectangle. So M is right in the center of the base. And when you drop the vertical down, that gives you a right angle at M. Now, we could do with finding the length AM. So if we draw our base flat, then because M is the center of the rectangle, those 2 lengths, remember the lengths of the square were 12 centimeters, those 2 lengths we can see marked in are both 6 centimeters. And so we can find AM using Pythagoras. So we've got AM is root 72. We then draw flat the triangle AEM, where AE, which is the sloping side of the pyramid, that AE there, that's 14 because it's exactly the same length as EC. All these lengths, these sloping lengths of the pyramid, they're all 14 centimeters. So now we're going to find X using SOHCAHTOA. Cosine ratio, and that will give us x equals 52.7 degrees. In our second pyramid example, what makes it different is when we mark the angle on ECB, so from E to C to B, that's the angle we're talking about, that isn't across the diagonal of the pyramid, that is just on one side of the pyramid. So if we take the triangle ECB, where angle X lies, and we draw that flat, it will look like that. Now note, importantly, that EB is one of the sloping lengths of the pyramid. So EB is the same length as EC. So in actual fact, this is an isosceles triangle. And that's a really useful property because it's isosceles. If we drop a vertical down, it splits the base exactly into two. So now on the right hand side now, we've got a right angle triangle. So cosine x is 6/14, and that's 64.6 degrees.